Hey guys, I am going to walk you through these problems, so you may walk through with me, or you can fast forward and just get to the problems that you want to see if you feel like you know how to do a lot of these. But this is essentially me going through it all with you. I'm not sure yet if it's going to be one big long video or several videos. I'm going to kind of see how long it's taking. So yeah, here we go. You should get answers to all of the questions as we go here. So let's start with number 1. When you're simplifying radical expressions, remember you're taking the square root of whatever can be square rooted. Everything here can actually be square rooted. So the square root of 49 is 7. The square root of x squared, remember you're just dividing by 2. So 2 divided by 2 is 1, so that's x to the first. And then y to the 10th, you're dividing by 2, so that's going to be y to the 5th. So everything is square rootable there, so that's your answer. Cube rooting, again, if we take the cube root of a negative 64, and your calculator will do that for you, you can just plug it in, that would be a negative 4. And then the cube root of y to the 9th, again, you're just dividing this number divided by that number. So that gives you y to the 3rd. Remember, you can think of it over here, like there's a 2, it's a square root, divide by 2 on that one, divide by 3 on this one, okay? Then it says multiply and simplify. If you look at this number 4 here, I would start by multiplying these two numbers. So it's going to be the cube root of 270. And then we can break that down. If we break that into what is cube rootable and what is not cube rootable, you can do 27, we can take a cube root of, 10, we cannot. Well, the cube root of 27 is 3, and then the cube root of 10, we just have to leave like that. Don't forget that little 3, right? Second one, if we multiply these, we would get 7 times 14 is 98. And then x to the 3rd times x. Remember, this is like x to the 1st. And when you multiply, you add the exponents. So that would be x to the 4th. Okay. Then we want to break this into things that we can square root and things that we cannot. So 98 has the perfect square of 49. Times 2, which 2 is not square rootable, right? And then you have x to the 4th, and you can square root that whole thing. What's a 4? My 4s are so terrible on here. So if we simplify that, the square root of 49 is 7. The square root of x to the 4th is x squared. Goodness. And then we have the square root of 2 that we can't do anything to. So it would look like that. Okay. Sorry, that's my daughter in the background. Okay, so for number 7, we are going to, lost my pens. We are going to rationalize the denominator by multiplying by 1, but we're going to make our 1 look a little different. Remember, this is where we do the square root of 3x over the square root of 3x, right? Whatever this is, we're going to multiply it over itself, so we're not changing anything, we're just multiplying by 1. So on top, you are going to have 1x is just x, right? So x rad 3x. On bottom, when you multiply a radical by itself, the radical goes away, right? We're taking the square root of 3x times the square root of 3x is the square root of 9x squared, which is 3x. So it looks like this right now, but x is divisible by x. That would be 1. So you are left with the square root of 3x over 3. And that would be your answer. Okay? Okay, number 8. We got to rationalize again. So we're going to get the square root of 5 out of there. So we multiply by 1. So on top, that would be the square root of 5x. On bottom, square root of 5 times square root of 5, sorry guys, that's my daughter, is the square root of 25, which is just 5. So this would be your answer. Okay. All right, number 10. We're foiling this. So we are going to do 7 times 1 plus 7 rad 5 plus the inside, which is 1 rad 5, I'm just going to call that rad 5, plus rad 5 times rad 5, which is the square root of 25, which is just 5. Okay, then we simplify from there. 7 plus 5 is 12, plus 7 rad 5 plus rad 5 is 8 rad 5. And then that we can't simplify any further, so that would be your answer. Okay. Number 12. Again, we're going to FOIL this. So first would be 5 times 2, which is 10. Outside would be minus, because of this minus right here, 5 rad 3. Inside would be plus 6 rad 3. And then last is 3 rad 3 times rad 3. Now, you can write this out fancier if you want. You're doing 3 rad 3 times rad 3, right? Think about that. That's 3 times rad 9, and rad 9 is 3, so that's really 3 times 3, which is 9. So this whole thing would be minus 9, okay, for your last there. Then if we simplify that, we're going to do 10 minus 9, so that's 1. And then we have negative 5 rad 3 plus 6 rad 3 would be a positive 1 rad 3. I'm not going to put the 1 in. You could put the 1 in. It's not a big deal if you do, but it should look like that. Okay. All right. This one. These ones could be a little tricky for some. Remember, we kind of think of this as two separate parts. So you're taking 27 to the 1/3 power, and then you're squaring it, or you're taking 27 to the 2nd power, and then you're cube rooting it. Remember, 27 to the 1/3 is the cube root of 27. Well, the cube root of 27 is 3, and then we square that. Okay, so 3 squared is 9, so 27 to the 2/3 power is 9. Okay, so let's look at this one over here. Now we need to take this 16th power to both of these powers that we already have. So this is going to be x to the, now we're going to do negative 3/8 times 16. Well, I would do, if I'm doing negative 3/8 times 16, I would think of it kind of like that and just cross cancel. So this would be 2 and 1. Negative 3 times 2 is negative 6. Okay, so that's x to the negative 6th power. And then you have y, and now we're doing 1/4 times 16, and 1/4 times 16, right? So 16 divided by 4 essentially is just 4. So we have this, but we need to simplify still, because you can't have negative exponents in a simplified answer. So our answer is going to be y to the 4th on top, because that's a positive. And when it's negative, we move it down or up, depending on where it starts. This one started as a numerator, so we're going to move it down, x to the 6th on bottom. Okay. All right, next one. So this one, we are going to solve by squaring both sides to get rid of the radical. So I get 2x plus 1 equals 25, and then we just solve. Take away 1, 24 equals 2x, and then divide by 2. So x is going to be 12 here. And you can always double check by plugging it back in. 12 times 2 is 24, plus 1 is 25. The square root of 25 is, in fact, 5. Okay. All right, number 20. If you remember these ones, we had to take this whole thing to the reciprocal power, right? To the 4/3 power would get rid of all of this. So we would just be left with x plus 6 on this side, but whatever you do to one side, you have to do to the other. So this equals 8 to the 4/3 power. Well, remember what we do with that. Basically what we're saying is this is 8 to the 1/3 power. and then we'll take that to the fourth power, and that just helps us think a little better, a little easier about what this would be. So basically we're saying the cube root of 8, which is 2. So it's 2 to the fourth power, and 2 to the fourth power is 16. Okay, so the right side is 16. The left side, we still have that x plus 6. So we're just going to take away 6 from both sides, and x would be 10. Okay. All right. On to the next page. So number 24 here, we are doing f of x is 3x plus 1, g of x is x squared plus 2, and they want us to find the value of each expression. If you remember, this is saying f of g of 2. So we want to start, if you recall, with the g, right? So the function of f after the function of g. So we got to start with g. So we're going to plug in this 2 into g, right? It's going to be 2 squared plus 2. Okay, so 4 plus 2 is 6. Okay, now we take that and then we plug that into our f of x function. So basically we're saying 3, sorry, the tops of my 3's don't want to work right now. 3 times 6 plus 1, so 3 times 6 is 18, 18 plus 1 is 19. So your final answer here is 19. Okay, we found 6, plugged that 6 in, and our final answer is 19. All right, so let's do the same thing for 25. Now this one switched it around, so we're going to do the f of x first, and then g. So they want us to plug a negative 3 in to our f of x function. So it's 3 times... Oh my goodness, why do my 3's not want to start where I start them? So it's 3 times negative 3 plus 1. Okay, so that would be a negative 9 plus 1, which is negative 8. Okay, and now we're going to plug that in to our g function. So it's going to be negative 8 squared plus 2. Right? And negative 8 squared is a positive 64, plus 2 would be 66. And that is your final answer. Okay. Number 26, they wrote the notation different, but it's the same thing. We're starting with f, and we're just plugging an x into it. So the nice thing about this is there's nothing you do to the beginning of it. We are literally plugging an x in for x. So we're getting this out of it. Okay, there's nothing you can simplify there. Now in place of x, we got to plug this into the g function. So this whole thing is going to go right here. So it's going to be 3x plus 1, and then we're squaring that. Okay, this is our x essentially, squared plus 2. Okay, now you could just leave it like that. That's a pretty simple way to do it, or you could actually square this binomial. If you do that, basically what you're doing is 3x plus 1 times 3x plus 1. When you FOIL that, you're going to get 9x squared plus 3x plus 3x plus 1. And then don't forget you have that plus 2. And if you simplify that, it's 9x squared plus 6x plus 3. So this could be your answer, or this could be your answer. I would take either one of those. All right, 27. This one is different. Remember when we found the inverse? Remember this negative 1? That means we're finding the inverse of the function for x. So right now, f of x is this. F of x equals 3x plus 1. Remember when we found the inverse, we switched our x and our y. So right now we're thinking of this as a y. We're going to switch this y and this x. So when we rewrite it, it's going to look like x equals 3y plus 1. And we're going to solve for y, and that's our inverse. So we're going to take away 1 on both sides. So 3y equals x minus 1. and then we're going to divide by 3. So we end up with y equals this, x minus 1 divided by 3. And that would be your inverse, okay? Technically, because it was in function notation, we would write the inverse of x equals x minus 1 over 3. I'm not super picky about that either. Okay. All right, now number 2 here, right? Our numbers are kind of all over the place just because of the setup of it. We are going to do, let's see, 4 to the 3/2 power. And we've done this in the first page. So basically what we're doing is we're taking the square root of 4, and then we're going to cube that, right? So the square root of 4 would be 2. 2 cubed is going to give us 8. So if you look at your options here, I would be your answer. Okay. This one, they tell you f of t is this, h of t is this, and they want to know the function for h of t plus f of t. So really what you're doing is you're taking t squared, right, h of t squared minus 2t minus 6, so this whole thing, and you are adding this whole thing, t squared plus 5t minus 2. So t squared plus t squared would be 2t squared. Negative 2t plus a positive 5t is going to be plus 3t. And then negative 6 plus negative 2 is going to be a negative 8. So your answer looks like that, and that was letter F. Okay. Number 9, h of x they give you, g of x they give you, and they want to know h of 1 minus g of 3. So we're going to plug in 1 to our h value. So it's going to be 2 times 1 squared plus 1 minus 5. This whole thing minus, now we're going to plug in a 3 for g. So negative 4 times 3 minus 1 is going to be that side. And then just simplify each one of those. So if we simplify this, 1 squared is 1 times 2 is 2. 2 plus 1 is 3. 3 minus 5 is negative 2. Minus, and now simplify this, negative 12 minus 1 is a negative 13. So we're doing negative 2 minus a negative, which is plus a positive. Negative 2 plus 13 is 11. So your answer is C. All right, last one here, and then I think I'll probably just stop and save this video and do another one for the next day. But if you want to work ahead, I'm fine with that. All right, this one, notice what these are. 4 minus 5 rad 3, 4 plus 5 rad 3. If you remember, those are called conjugates. And when we do conjugates as binomials like this, when we multiply them, you could FOIL it. You could go first, outer, inner, last, and you would get the right answer. It's just extra steps because there's a shortcut when you do the conjugates. Remember what we do was we square the first term, so 16, I don't need parentheses, 16 there. Then you square the second term. So you are squaring 5 rad 3, right? Which means you're squaring the 5, which is 25, and you're squaring the square root of 3. Well, the square root of 3 squared is just 3. So 25 times 3 is 75. Okay, so that's going to go here, 75. And then we subtract them. Remember, 1 is minus, 1 is plus. We always subtract in that scenario. So 16 minus 65, you get a negative 59. Okay, so that's the first 2 pages. That's the first assignment that's due.